Let's start now. Rocky moons. When most people imagine a moon, they picture a gray, crater-covered world hanging silently in space. This is the classic type of moon, the rocky moon. Rocky moons are composed mostly of solid rock and metal, much like the inner planets of our solar system. Their surfaces are often marked by ancient craters, mountains, and vast plains formed billions of years ago. The most familiar example is Earth's own natural satellite, the Moon. Our Moon formed around 4.5 billion years ago, likely after a massive collision between the young Earth and a Mars-sized object. The debris from that impact eventually gathered together and formed the Moon we see today. Unlike Earth, rocky moons usually lack thick atmospheres. Without wind, rain, or flowing water to reshape their surfaces, impact craters can remain visible for billions of years. But rocky moons are far from boring. Their silent landscapes preserve a record of the violent early history of our solar system. Every crater tells a story of ancient impacts when asteroids and comets constantly bombarded young worlds. Some of these impacts were so powerful they reshaped entire regions of the lunar surface. Giant impact basins later filled with lava, forming the darker plains we see today from Earth. Rocky moons are the most familiar members of the Moon family, but many moons are far stranger. Icy moons travel farther from the Sun, and temperatures drop dramatically. In these colder regions, many moons are made primarily of ice rather than rock. These are icy moons. Instead of solid stone landscapes, their surfaces are dominated by frozen water, ammonia, and methane. Under the right conditions, these frozen worlds can become some of the most intriguing places in the solar system. One of the most famous examples is Europa. Europa looks smooth and bright from space, covered with a cracked shell of ice resembling a giant frozen puzzle. But beneath that icy crust, scientists believe something incredible may exist: a vast global ocean. This hidden ocean could contain more than twice the amount of water found in all of Earth's oceans combined. If heat from Jupiter's gravitational pull keeps this ocean liquid, Europa might even contain environments capable of supporting life. The cracks covering Europa's surface may actually be places where warmer water rises from below and refreezes on the surface. Some scientists believe that one day robotic missions may drill through the ice to explore the ocean hidden beneath. Icy moons may look frozen and lifeless from the outside, but beneath their surfaces, they could hide entire alien oceans. Giant moons. Some moons are so large they almost qualify as planets themselves. These are known as giant moons. The largest moon in the entire solar system is Ganymede. Ganymede is so massive that it is actually larger than the planet Mercury. It contains its own magnetic field, something extremely rare for a moon. Beneath its icy surface, scientists suspect it may contain multiple layers of underground oceans stacked between layers of ice. If Ganymede orbited the Sun instead of Jupiter, it might easily be classified as a planet. Its diameter stretches over 5,200 kilometers, making it larger than many worlds once considered planets. Despite its enormous size, Ganymede quietly circles Jupiter once every 7 days, locked in a gravitational relationship with the giant planet. These enormous moons blur the line between moons and planets, reminding us that nature does not always follow our neat categories. Ocean moons. Some moons may contain one of the most important ingredients for life: liquid water. Ocean moons are worlds believed to hide massive subsurface oceans beneath thick layers of ice. One of the strongest candidates is again Europa, but another remarkable example is Enceladus. Enceladus appears small and bright, but spacecraft have observed gigantic plumes of water vapor erupting from cracks in its icy surface. These plumes shoot hundreds of kilometers into space. When scientists analyzed the material inside them, they discovered something extraordinary: organic molecules, salts, and hydrogen gas, all ingredients that could potentially support microbial life. These findings suggest that deep beneath the frozen crust, chemical reactions may be occurring between water and warm rock. On Earth, similar reactions near deep ocean vents support entire ecosystems of living organisms. Some scientists believe the oceans beneath Enceladus may be one of the best places in the solar system to search for alien life. Geologically active moons. Not all moons are frozen or silent. Some are violently active worlds. The most extreme example is Io. Io is the most volcanically active body in the entire solar system. More than 400 active volcanoes constantly reshape its surface. Massive eruptions blast sulfur and lava hundreds of kilometers above the surface, creating glowing plumes visible from space. This intense activity is caused by tidal forces. As Io orbits Jupiter, the giant planet's gravity constantly stretches and squeezes the moon. That constant flexing generates enormous heat inside Io's interior, fueling its extreme volcanic activity. Some eruptions are so powerful that they can be seen from telescopes on Earth. Instead of being quiet and frozen, Io is a world of constant fire and eruption. Cryovolcanic moons. While Io erupts molten rock, other moons erupt something far stranger. Ice. These are cryovolcanic moons. Instead of lava, their volcanoes eject water, ammonia, methane, or other frozen compounds. Massive geysers erupt from fractures near its south pole, blasting icy particles into space at incredible speeds. These particles even help feed one of Saturn's outer rings. Cryovolcanos reveal that even small, frozen moons can have surprisingly active interiors. The energy driving these eruptions may come from gravitational interactions with nearby planets. As these moons orbit, their interiors heat up slightly, allowing liquid reservoirs to form beneath their icy shells. Deep below their icy crusts, hidden oceans and heat sources may still exist. Atmosphere moons. Most moons have little or no atmosphere. But one moon stands out as a remarkable exception. That moon is Titan. Titan possesses a thick orange atmosphere even denser than Earth's. Its skies are filled with clouds, storms, and rain. But Titan's rivers and lakes are not made of water. They are made of liquid methane and ethane. Entire seas of hydrocarbons stretch across its surface. Titan is the only place in the solar system besides Earth known to have stable liquids on its surface. The moon also experiences seasons, weather cycles, and rainfall, although the chemistry is completely alien. But its alien chemistry makes it one of the strangest environments we have ever discovered. Captured moons. Not every moon formed alongside the planet it orbits. Some are cosmic prisoners. Captured moons are objects that once traveled through space independently before being trapped by a planet's gravity. A famous example is Triton. Triton orbits Neptune in the opposite direction of the planet's rotation. This unusual retrograde orbit strongly suggests Triton was once a dwarf planet that Neptune captured long ago. After being captured, Triton's gravity interactions likely destroyed or ejected other moons that once orbited Neptune. Today, Triton remains one of the coldest known worlds, yet it still displays strange geysers that erupt nitrogen gas into space. A captured moon is a reminder that planetary systems are chaotic places where wandering worlds can be captured and transformed. Shepherd moons. Some moons act like cosmic shepherds. Shepherd moons orbit near planetary rings and use their gravity to keep the rings organized. One example is Prometheus. As Prometheus travels through Saturn's rings, its gravity pulls and shapes streams of icy particles. Without shepherd moons, planetary rings would quickly spread out and disappear. Instead, these tiny moons help maintain some of the most beautiful structures in the solar system. Their gravitational influence can carve sharp edges and gaps in the rings. This constant interaction creates some of the delicate patterns seen in images of Saturn's ring system, ring moons. Some moons do something even stranger. They orbit directly within a planet's ring system. One famous example is Pan. Pan travels inside Saturn's A ring, carving a gap known as the Encke gap. As it moves through the ring particles, it constantly reshapes the surrounding material. Small particles collide and bounce around the moon as it passes through the ring. Over time, this process changes both the structure of the ring and the shape of the moon itself. But Pan is famous for another reason: its bizarre shape. Co-Orbital Moons. Some moons perform a delicate gravitational dance. These are co-orbital moons. A fascinating pair is Janus and Epimetheus. they share nearly the same orbit around Saturn. Every few years, the moons approach each other and exchange orbital positions. Instead of colliding, they swap places in a perfectly choreographed gravitational dance. As they approach each other, gravity slightly changes their speeds. One moon moves outward into a higher orbit while the other shifts inward. This behavior is extremely rare and highlights how complex orbital mechanics can be. Trojan moons. Some moons hide in special gravitational zones called Lagrange points. These locations allow objects to remain stable while sharing the same orbit as a larger moon. An example is Telesto. Trojan moons follow larger moons like silent companions, staying in stable gravitational pockets for millions of years. Because gravity balances perfectly at these locations, objects can remain there almost indefinitely. Entire clusters of asteroids and small moons may gather in these gravitational safe zones. Binary moons. Some systems blur the line between planet and moon. A famous example is the relationship between Pluto and Charon. Charon is so large compared to Pluto that the two objects orbit a point in space located outside Pluto itself. This means they effectively orbit each other. Both worlds are locked in tidal synchronization, meaning the same sides always face each other. From Pluto's surface, Charon would appear enormous in the sky. Some scientists describe them as a binary system rather than a simple planet and moon. Temporary moons. Even Earth occasionally captures a moon. Temporary moons are small asteroids that briefly become trapped in Earth's gravity before escaping again. One such object was 2020 CD3. For several years, it quietly orbited Earth before drifting back into space. Objects like this are sometimes called mini-moons. Because they are small and faint, many of them likely pass through Earth's gravitational influence without ever being noticed. At times, our planet may host tiny invisible moons without us even realizing it. Exomoons. Finally, we reach one of the most mysterious categories of all. Exomoons. These are moons orbiting planets outside our solar system. Astronomers have discovered thousands of exoplanets, but detecting their moons is far more difficult. One candidate system involves Kepler 1625b. Evidence suggests it may host a gigantic moon, possibly the size of Neptune. If confirmed, it would be the first known moon discovered beyond our solar system, and it would open a completely new chapter in astronomy. Because if planets have moons across the galaxy, some of those moons could even be habitable worlds. From familiar rocky companions to ravioli-shaped worlds and alien oceans hidden beneath ice, moons come in far more varieties than most people imagine. Each one reveals something new about how planetary systems form and evolve. And with new telescopes searching distant star systems, we may soon discover even stranger moons waiting in the darkness of space. If you enjoy exploring mysteries of the universe, subscribe to Paint Facts for more videos like this.